Hello there, you're welcome to Biology Lectures with Akerele Oladimiji Philip. So today we'll move on to question 4 on the A-level solving past question series. Here it says a student investigated the effect of chewing on digestion of starch in cooked wheat. He devised the laboratory model of stomach digestion in the human gut. This is the method he used. 1. Volunteers chewed cooked wheat for a set of time. The wheat had been cooked in boiling water. This chewed wheat was mixed with water, hydrochloric acid, and protein digesting enzyme and left at 37 degrees Celsius for 30 minutes. A buffer was then added to bring the pH to 6.0 and pancreatic amylase was added. This mixture was then left at 37 degrees Celsius for 120 minutes. Samples of the mixture were removed at 0, 10, 20, 40, 50, 60, and 120 minutes. You might just want to pause the video here and read all through. And the concentration of the reducing sugar is in each sample was measured. Controlled experiments were carried out using cooked wheat that had been chopped up in a blender, not chewed. A. What reducing sugar or sugars would you expect to be produced during chewing? Give a reason for your answer. Well, basically, for the fact that it says here cooked starch, that's a major point to remember. That's cooked starch. Being cooked starch demands that and it's in the mouth, and we expect to form maltase. Maltase and enzyme maltose. Now, what do I mean? In the mouth, there's an enzyme, the salivary amylase, which converts cooked starch to maltose, and maltose is a reducing sugar. I think I should make mention of reducing sugar generally. Example of reducing sugar are all the monosaccharides, the glucose, the fructose, the galactose, the maltose, and the lactose. So these 2 are disaccharide, these 3 are monosaccharide. So all of these are reducing sugar, basically. All right. Now it says give reason for your answer. Well, the reason is because the mouth contains salivary amylase, which converts cooked, sorry, I didn't write this in sentence anyways, cooked starch to maltose. Just writing which the mouth contains salivary amylase is enough to give you your answer sincerely. All right. Okay. In this model of digestion in the human gut, what other enzyme is required for the complete digestion of starch? Okay, well, basically, you should know that in digestion, you are trying to convert polysaccharide into disaccharide, then into monosaccharide. So it means that in this instance, the starch in the wheat is the polysaccharide. It's being converted by salivary amylase into maltose. To convert maltose to its component, which is glucose plus glucose, you need an enzyme here called maltase. which is secreted in the wall of the small intestine. So to bring about that, so you need maltase. You may want to remind yourself that this this disaccharide, which is maltose, has 2 glucose in it. Then another disaccharide, the likes of sucrose. So sucrose is made up of glucose plus fructose. Then another disaccharide, which is lactose, is made up of glucose and galactose. I just felt I should remind you of these ones. Basically, it's solving past questions and demands that you remember some things. All right. So moving on. What was the purpose of step 2, in which samples were mixed with water, hydrochloric acid, and pepsin? This chewed wheat was mixed with water, hydrochloric acid, and protein digesting enzyme. Oh, that is pepsin, because this has a similitude to the stomach. How? The fact that it has hydrochloric acid. Yes. Then now, protein digesting enzyme. And the protein digesting enzyme we have in the stomach is only one. Pepsin. So, okay. What was the purpose? Okay. I think, okay, it is to model or mimic the stomach. Yeah, that's the aim of that. Now, in the control experiment, cooked wheat was chopped up to copy the effect of chewing. Suggest a more appropriate control experiment. Now, in the control experiment, you're supposed to have virtually everything the same, but let me just change the variable. So in this instance, the wheat, sorry, let me write that in the proper way. The wheat should have been chewed also, all right, but mixed with boiled saliva. Boiled saliva. Now, the boiled saliva means it is denatured. So that means salivary amylase is denatured. Salivary amylase is denatured. Why? Because we've boiled it. So this is the control experiment here. The truth is the salivary amylase, sorry, the chewing makes it equal. So like the way you chew the first one, the way you're supposed to chew this the other one. But for the fact that you've changed you've denatured the amylase, that shows that you are trying to say that the temperature should not be too much in digesting. So that means the only variable you changed here is the temperature, or let me say you're trying to prove the fact that the digestion ought to occur under normal temperature, which is 37 degrees Celsius, which is the normal body temperature. But when you boil it, that's about 100 degrees. So you've denatured the salivary amylase. So in this is a control experiment to show that you need the appropriate temperature for this to happen. So this is what it should be normally. Okay. I think we have information here. The figure shows the student's result. Okay. Explain what these results suggest about the effect of chewing on the wheat. Okay. The broken line here is the chewed cooked wheat. This is chopped one. Oh, okay. Okay, well, generally speaking, what I could see here is that okay, presence of salivary amylase makes, please just pardon I'm just trying not to, pardon my handwriting please, makes the chewed cooked starch to digest faster. You could see what's happening here. Even at 0 minutes, you already have a value of about 50 something in the mean concentration of sugar, reducing sugar in sample cooked wheat per milligram per gram, so to say. All right, so then we can also say here that yeah, this also shows that the wheat has already been digested. Then also, if you look at this part here, both conditions still resulted in the same product, or let me say just same product. What I'm trying to say here is that both, whether it was chopped or it was chewed, we still ended up having the same products. I mean, the same final digestion, really. All right, it's like the same thing. The only thing was that it was slower. You know, we always know that what enzymes does is to make digestion faster. So it doesn't mean, I mean, so it will still happen, digestion will still happen, but because of the presence of enzymes in that reaction, is going to be faster. So this one was faster, this was quite faster because there was enzyme, but this was slower, but the end result is the same. I would advise you, just because of that, I didn't say that, you might also, there's nothing wrong if you make mention of values. You say for the chopped cooked wheat at 20 minutes, the value was this, but for the chewed one, for the chewed cooked wheat, the value was 200 something at the same time, just to show the time the effect of enzyme in timing. So it means that even at the same 20 minutes, we have more product being digested at with the one that has chewed starch. All right.